हो गया मैम, हो गया मैम, अभी हो गया। ओके 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 ओके। Okay, so welcome everyone. Hello. Uh, so yeah, in today's session also we will take up previous year questions itself. So yeah, this is the first problem. You guys can try it out. Hello, hi Arun, hi Ria. Okay, so first question, it's a dimension problem. It's a very easy problem. So in dimension problem, usually pick up the easiest quantity that is given first, right? So in this question, firstly we have the pressure, right? So pressure's dimension, we can find it out as dimension of force divided by area, right? Now force is mass times acceleration, and area's dimension is length square, so that matches up with option 1. So C matches up with 1, and then you can take like surface energy or surface tension, and you can get the answer. Okay, option 2, yeah, it is option, let's see, option 2, yes. These questions are mainly from 2025 and 26. So after question 40, most of the questions are from April shifts. Okay, this shift basically. So next is Vernier caliper problem. It's given that 50 Vernier scale divisions are equal to 48 main scale divisions. Now, what does that mean? It means the lengths are equal. 50 Vernier scale divisions would mean 50 multiplied with, now one Vernier scale division length, let's take it as x in x millimeter. Okay, so 50x equals 48 main scale divisions. Now it's given that one main scale division is 0.05, right? So 48 times 0.05. So from here you can get x, which is one Vernier scale division. Okay, and the least count, this formula most of you must be knowing. It's one main scale division minus one Vernier scale division, and I guess, yeah, once you solve it, the answer will be option 1. Okay, okay, so how many of you are having exams on 8th? I guess all of you are having exams on 8th, right? So yeah, moving on. So next question. So this is like percentage error. You have to find the percentage error in viscosity, coefficient of viscosity. And we have to ignore the errors associated with density and G. Okay, so if you remember the formula, so this is the Stokes law expression, right? When we have a small sphere dropping through a viscous medium, a viscous liquid, the formula for terminal velocity, this is a pretty important formula for mains. This is 2 by 9 r square G, density of object minus density of liquid divided by coefficient of viscosity, right? So okay, so your Alex, your shift is done. All right, so here we will rearrange for eta and write it in terms of, so we only want the errors associated with terminal velocity and the radius, right? So everything else we can just ignore. So eta equals constant multiplied with r square divided by the terminal velocity. Okay, terminal velocity, they have taken the symbol O, V naught. So now you can write the percentage error formula, delta eta divided by eta. times 100 equals 2 delta R by R plus delta V naught divided by V naught, and that would be it. So option C is the answer. Okay. So maximum percentage error, whenever they ask, it's just remember the formula, rearrange so that the term whose percentage error you need comes on the left side, everything else on the right side, and then it's the usual formula. Okay. So yeah. Okay, so now it's a problem on vectors. We have two vectors, A vector and B vector. Magnitude of component of vector A along the vector B will be. Okay, so this is a projection question. So component of A along B. So we have two vectors. Vector A and vector B, something like this. So when we say the component of A along B, what does that mean? We drop a perpendicular onto B. Okay. Now if this angle is theta, this length A cos theta. So A is modulus of A. Okay. Modulus of A cos theta. This is the magnitude of the component along B vector. Okay. So yes, so we use dot product here. Okay, so we need magnitude of A into cos theta, right? So magnitude of A, magnitude of B cos theta is A dot B. So this is nothing but A vector dot B vector divided by magnitude of B vector. Okay. So now once you do this, the answer will turn out to be 2, okay, 2 meters. Okay. Next, another vectors problem. So sum of two forces P vector and Q vector is R vector, and the magnitude of R vector is given to be equal to magnitude of P vector. So R vector is the resultant of P and Q, and its magnitude is equal to P vector. So these questions, I mean, sometimes it's useful to draw the vector diagram, okay, and just see how the vectors look. P and Q. So let's say this is Q vector, and let's say this is P vector. So this will be the resultant vector. Okay. So this is Q, this is P, and this is the resultant vector. Okay, so this side length is equal to this side length because their magnitudes are given to be equal. Okay, the angle theta in degrees, that the resultant of 2, so this will be 2p. Okay, 2p vector and q vector will make with q vectors. So what is 2p vector? So we have p vector in this direction. 2p vector will be p vector plus another p vector in the same direction, right? So on top of this p vector, we'll have to add just another p vector like this. So p plus p is just 2p. Now this 2p vector, we have to add it with q vector, which was the original vector itself. So what is the new vector? The new resultant will be this vector, right? Q vector plus 2p vector. The blue vector will be the new resultant, which is r dash, let's say. So we ultimately want what is the angle between r dash and this q vector. Okay, so this length and this length are equal. So if these two lengths are equal, if I say this angle is some theta, this angle will also be theta, right? Because the lengths are equal. And if I say this angle is alpha, this angle will also be alpha because these two side lengths are equal in this triangle. So from here, if I say what is the total angle, total sum of these three angles, it's alpha plus theta that is these two, and this is alpha plus theta, so plus another alpha plus theta. The sum of these three angles must be 180. So from here we get alpha plus theta is 90, right? And alpha plus theta is the angle we needed. So the answer will be 90 degrees, okay? We needed that angle between R dash and Q, okay? I mean, otherwise there is also another property, if you guys recognized it, and that is, if you, what was that property? There was a property regarding right triangles, I guess, in which if you draw the median from this right angle to the opposite side, these three side lengths are equal, right? Something like that. There is a triangle property, I guess. So with that you can just directly comment this is 90 degree. So yeah, please explain this one more time. Okay, yeah, sure. So it's just vector resultant, okay? So you have two vectors P and Q. So I drew Q at the bottom, Q vector plus P vector. This is the first resultant of them, which is R vector, okay? Now it's given magnitude of R and magnitude of P are equal. What is magnitude? It's the side length, right? So this side length and this side length are equal. That's why I have mentioned it using a white cross, right? This means these two side lengths are equal. Now, if these two side lengths are equal, these two angles will also be equal, right? Triangle properties. Now the second information is we have 2p vector and q vector in the second case. Now what is 2p vector? It's 2p in this direction. This is the direction of p vector. So p vector plus another p vector. What is p plus p? It will be 2p. So this whole hypotenuse thing, this whole side length is 2p. 2p added to q, right? 2p and q. The resultant of that is going to be this blue vector. So the question is, what is the angle between this r dash and this q, which is this angle? Okay, it's a mess now, but which is this whole angle. Okay, and that angle is actually alpha plus theta, if you look at the diagram, and alpha plus theta is going to be 90. So that is the answer. Previous question of vectors. Yeah. So in this question, the topic was we need to find the magnitude of component of vector A along vector B. So there are two vectors, and they are given to us in Cartesian form. Okay. Now what is a component of any vector along another vector? So so this is A vector, this is B vector. Now A vector we can split it into, if you want the component, you drop a perpendicular onto the other vector. This particular length is the component of A along the direction of B. Okay, now using trigonometry, this length is A cos theta. So we want A cos theta. So that is the question. Now how do we find cos theta? Cos theta is the angle between two vectors, right? So we use dot product to find cos theta. So A dot B is mod A mod B cos theta. So using this we get cos theta, but we want A cos theta, right? So instead what we did is we took this B and brought it here. So that will be A vector dot B vector divided by B, and this is actually A cos theta. So if you do this, you will get A cos theta, which is the answer. And A dot B you can simply do, mod B will be, I think there was a 2 here, I guess. So that this becomes 9. So mod B, if you do, it will be root of 1 plus 4 plus 4. Yeah, I guess this was I plus 2j plus 2k. Okay. All right. I hope that is clear. This is the next problem. So try it out once. Projection along V formula in maths. Yes. So this is a kinematics problem. A paratrooper jumps from an aeroplane, opens parachute after 2 seconds of free fall. Okay, so he free falls for 2 seconds. So let's say he started from this height level. So if he free falls for 2 seconds, then Okay, so what is the value of g? G value is 10. So velocity will be gt, right? So 20 meters per second. So he fell down some distance. This distance is half gt square, which is half g2 square, 20 meters. So this length is 20 meters and his current speed is 20 meters per second. So this is his situation after 2 seconds. Now after this he starts to decelerate with 3 meters per second square. Okay, so now instead, now he starts to decelerate at 10 meter height from the ground while descending with the help of parachute. The speed of paratrooper is 5 meters per second. Okay, so now we are talking with respect to the ground. So this man is at a height of 10 meters from the ground, and over here his speed is 5 meters per second. Okay, now the question is, what is the initial height of the aeroplane? So let's just say this length is y. So the answer is y plus 10 plus 20. So we need to find y. So basically from this location to this location, his deceleration is 3 meters per second square. We know initial velocity and final velocity, right? So v minus u is equal to at. Acceleration is minus 3. So minus 3 into t. Time will be 5 seconds. Okay. So to go from here to here, he took 5 seconds. So now we can use s equals ut plus half at square once and get the distance. Okay. So this distance y, displacement y, initial velocity is 20. So 20 into the time is 5, plus half gt square, and acceleration is minus 3. So minus half into 3 into 5 square. Okay, and once you solve this, y plus 20 plus 10 will give you the answer as 62.5. Okay. So you guys can fully solve the questions after the session, okay, tomorrow maybe. So just to save on time, I am not doing the calculations fully. Next question, we have an object of mass m. It's projected from the origin in a vertical xy plane, angle 45 degree with the x-axis, projectile motion, right? Initial velocity is given, magnitude and direction of the angular momentum. So this is what we have to find with respect to the origin when it reaches the maximum height point. Okay, so that is the question. So we have a particle projected from the ground. It makes v0, this angle is 45 degree. So in the maximum height position over here, what exactly is the speed? Firstly, the speed is horizontal, velocity is horizontal, and the magnitude of the speed is v0 cos theta, which is v0 by root 2. For angular momentum, so we need the angular momentum with respect to the starting point, right? So angular momentum of the particle is just m r vector cross v vector, right? Or just for the magnitude, we can say it is mv into r perpendicular. So this is going to be r vector, but because the velocity is along the x direction, the magnitude of L will be mv into r perpendicular, right? And the perpendicular distance is this length. This is actually the max height. This is h max. So the answer will be mass v0 by root 2 into h max. H max formula is v0 square sine square theta divided by 2g. So v0 square by 4g. Sine square 45 will be half, so in the denominator we will have a 4. So the magnitude of angular momentum will be m velocity at the top is v naught by root 2 speed times v naught square by 4g. This is the magnitude. Now for direction, it's in the direction of r vector cross v vector. So r vector is in this direction, right? R vector is along the blue vector. If you cross it with v, r cross v is actually into the page, right? This is r vector's direction. This is v vector's direction. If you do r cross v, it will be into the page. Into the page is the minus z direction, minus k cap. So it will be fourth option, mv naught cube by denominator we have a 4 root 3 along the negative z direction. Okay. So next question, trajectory of a projectile is given. So the equation of trajectory is given. Okay. Where x and y are measured in meter, the maximum height attained by the projectile will be. I mean, this we can just solve with solve using the maths idea, right? So this is actually the, this is somehow this is how the projectile motion will look like. We need to find the h max, right? So actually the coordinate of this vertex of the parabola, this is given to us by minus b by 2a comma minus d by 4a, right? So what we need is the minus d by 4a. So that's what we have to do. So here the parabola is minus x square by 20 and plus x equal to y. So a can be, a is equal to minus 1 by 20, b is equal to minus 1 and c is equal to 0, right? If we compare it with ax square plus bx plus c. So what is the discriminant? It will be root of minus b square minus 4ac, right? So it will be 1 basically, right? Because c is 0, so d value will be 1. So the answer, so this is the y coordinate which is equal to h. So minus 1 divided by 4 into a is minus 1 by 20. So that way also you can get the height, which is actually 5 meters. Yeah, that also works. If you do dh by dt, dy by dx by dt is equal to 0, what happens is you will get the x coordinate and then you will have to put the x coordinate over there. You can use calculus also. Okay, next question. We have a particle moving in a circle whose radius is capital R. It's uniform circular motion and it takes time t to complete one revolution. Okay, so time t will be distance covered divided by speed. So using this relation we get the speed. If the particle is projected with the same speed at an angle theta, so now we have projectile motion. What is the maximum height attained by the, okay, it's given maximum height is equal to 4r. Then we need the angle of projection. Okay, so this is a formula based problem. So h max, which is equal to 4r, this is equal to the speed square sine square theta divided by 2g. Okay, so now you just have to put v from here over here and you will get the answer. I guess it will be the second option. No, in the, yeah, it's either the first or the second. You guys can compare. Equation of trajectory, yeah, that also we can use. There are multiple ways to do it. Equation of trajectory, if you want to use, it will be x tan theta. So comparing it with that, tan theta becomes 1 minus half gx square upon u square cos square theta. Then from there you can get u and then you can find h max using the formula. Okay. So this question is just two formulas only time period in uniform circular motion, and maximum height in projectile motion. Okay. Okay, so this is the next question. Try it out. Okay, so here we have a coin placed on a disc. Coefficient of friction between the coin and the disc is mu. Distance of the coin from the center of the disc is r. The maximum angular velocity which can be given to the disc so that the coin does not slip away is. Okay, situation is we have a rotating disc which is large. Okay, it's rotating with some angular velocity. And at a radial distance of r from the center, there is a tiny coin placed over here, okay, which can be considered as a particle. So we need to find what is the minimum mu, or what is the mu value so that the coin does not slip away. So basically, if the coin does not slip away, it should move in the same circular motion. It should move in this circular motion, right? So you can use the centrifugal force instead. So if I solve the problem with respect to the disc, the centrifugal force will be in this direction, okay, and its magnitude is m omega square r. Who is balancing the m omega square r? It is the inward friction force, right? So m omega square r should not cross the maximum friction. So m omega square r should be less than max friction. What is max friction? Mu times the normal, which is mu mg. Okay, which means omega square, omega should be less than root of mu g by r. Second option. Okay, so omega must be less than or equal to this value, otherwise the coin will slip. Okay. Given object takes n times the time to slide down 45-degree rough inclined plane as it takes to slide down an perfectly smooth inclined plane. So we have a 45-degree inclined plane. In the rough case, it takes n times more as compared to the smooth case. Then the question is, what is the kinetic friction coefficient between the surface and the object? Okay. So if we have some object, okay, and it is slipping downwards, if its acceleration is, let's say, a, and the length of the incline is L, so the time taken we can easily write it as square root of 2L divided by A. Okay, this is simply distance displacement equals half AT square. Okay, rearrange and you will get that formula. Now in the smooth case, A is, in the smooth case, A will be g sine theta, and in the rough case, the only difference is there will be a mu mg cos theta upwards. So the acceleration will be g sine theta minus a mu g cos theta. Okay, this is the only difference. The length remains the same, right? So time in the rough case divided by time in the smooth case. This is given to be n, and this is equal to square root of, so rough divided by smooth. So in the rough case, so here we will have a sine theta, and here we will have a sine theta minus mu cos theta. So now it's theta equals 45. So sine 45 and cos 45 are the same, so they cancel out. So now you just have to solve for mu. Okay, so answer will be the first answer. Why is friction towards the center? Yeah, so that is because there is no tangential acceleration, right? It is rotating with constant omega. So if it is rotating with constant omega, the only force is the centrifugal force in the radially outward direction. So friction will act so that the net force is 0, right? So which means it must act towards the center. So I am solving with respect to the disk's frame, right? That's why I am using the centrifugal force here. So if you assume the disk is at rest, then what will happen? We'll have to apply the centrifugal force, which is radially outward, m omega square r. So who's going to balance this m omega square r? It's the friction force that acts towards the center. Centrifugal is radially outwards, so friction will be towards the center. Okay, and these two must balance out and the coin will be at rest. Okay, if there was some angular acceleration as well, alpha, then the coin will have an r alpha as well. So friction will have a tangential component also. Okay. Yeah, in the ground, with respect to ground frame, if you are writing, then friction provides the centripetal force. That way also you can look at the same problem. Okay. So this question, I hope it is clear. Okay, so next question, block trolley system, coefficient of friction. Okay, so there is friction between the 20 kg block and kinetic friction, I mean ground. The coefficient of friction is 0.04. So we can find out the kinetic friction, right? It will be 0.04 mu mass into g. So this is 8 Newton. So friction force is 8 Newton. Now you can like make this block horizontal, something like this. This is 6 kg, and the 60 Newton will also become horizontal. Okay, so if you make this vertical part horizontal, the acceleration of both these systems are identical. Okay, so you can think of this like a train now. So there is a rightward force of 60, a leftward force of 8 Newton. What is 60 minus 8? It is 60 minus 8 is 52 Newton. So this is the net force to the right divided by the net mass. Net mass is 20 plus 6, 26. So this is 2 meters per second square to the right, if you imagine it like a train. But actually what will happen is this block will move down with 2 meters per second square, and this will move to the right with 2 meters per second square. This is just another way to imagine it. Okay. Alright. So 2 will be the answer. This question also you can do it the same way. We have two masses m1 and m2. Acceleration is given as g by 8. We need the ratio of masses. So larger mass divided by the smaller mass. Okay. Ratio of masses is what we have to find. m2 by m1. So let's just say it is k. So if I say the smaller mass is some m, the larger mass will be km. Okay. So which will, now you must know the formula for Atwood machine, right? It will be kmg minus mg divided by the total mass, which is km plus small m. This is going to be g by 8. Okay, so I guess now you can solve it. You can just cancel out m and solve for k. I guess the answer would be 9 by 7 maybe. Second option. Yeah, 9 by 7. So yeah. All right. This question also is the same. You can find out this force, let's call it F1, then find this force, let's call it F2, and you can make it into a horizontal train like two problems before, and then it will be like F2 minus F1, whichever is larger, divided by total mass. Okay, then you will get the acceleration. Okay, so these problems you can like convert this into a horizontal train and solve the problem. In the friction question, you mean, I guess you mean this one? Yeah, the other way is to, write down two equations. First write F equal to ma for the 20 kg one. So there will be tension force. So T minus 8 equals 20 into A, and then the same tension will apply to this block. Write F equal to ma for them, eliminate tension. Yeah, we can make train every time. Just make sure the forces are also like, so like for example, if you rotate this system by 90, this 60 in the down will become 60 to the right. Okay, so just make sure of that. So like in this question, like for example, there is an mg downwards and a kmg in this direction, right? So if you like open it up into a horizontal train, the m will be like this, then we'll have a km like this, but this down kmg becomes a right kmg, and this down mg, we opened it up like this, right? So this is towards the left, and now we'll say the train has some acceleration a, and now we can apply it once again. Okay, this is that formula, m2 minus m1 into g is the net rightward force, m2g minus m1g is the net force, equals net mass into acceleration. Okay, this you must remember, it's the Atwood machine acceleration formula. Yes, it is for 8th April. But you say I didn't get. Which question you didn't get? Ichigo. $20 marks, I mean nobody can say, right? If you solve the April shifts question, you can definitely get 20. Like the papers that were conducted so far, if you just go through the solutions of them, you can easily get 20. 2m1 m2, that was for tension, Ishigo. That was like if you want the tension in the string, that it was a formula for that. Okay, 2m1 m2 upon m1 plus m2 into g, that would be the tension. Okay, this also you can do the train thing. The train is to basically find the acceleration. Like if you have like two masses connected like this and they are moving with a common acceleration, you can use that train trick. The 2 equation 1 I didn't get by that. 2 equation 1. This question you mean? Session till there is about 70 questions, so I think it will be around max 130 or 2. Okay, you can try it out. Okay, after session just sit down and try it out, you will get the answer. Okay, so yeah, so now this question, we have a mass of 2 kg. It is moving along the x direction such that its displacement is a function of time. X as a function of time is given, so this will be alpha is 1, beta is 1, gamma is also 1. So basically t square plus t plus 1. This is the x function, displacement function. So the question is, what is the work done on the body in the time interval from 2 to 3 seconds? So I guess there is some force acting on the body, right? You can also find out its acceleration. That force will do some work, and we need the work from 2 to 3 seconds. Okay. Yeah, there are a lot of repeated topics, Aditya. You should just download the papers and check, like logic gates, right? This is like very common. That surface energy problem, right? Usually an easy AC problem is also being asked, something related to the RLC, the impedance, or they sometimes ask about the power factor, right? So there is an easy AC question repeating, also the resonance formula, right? Resonance one. What else is repeating? You should take a look at the April shift problem. Session time I told you, bro, like it is around 1:30 am. Integration f dot ds. Yeah, that is also possible, or you can use work energy theorem. Okay, just change in kinetic energy. Okay, so which will be half m v2 square minus v1 square. This will also give you the answer. Okay, find velocity at t equal to 3, velocity at t equal to 1, substitute That will also give you the answer. Physics may I can do everything, problem is organic. Yeah, all of us have some like strong topics and weak topics, right? Physics is also just coming very easy. Okay, so this question, there is a printing error here. This is not 2 meter, this is 2 meter, okay. This 2 meter length is before the spring. Okay, so the spring is over here. The length before the spring from here to here, that is 2 meters, okay. So we have a block released from here, top of the inclined plane. The maximum compression in the spring when the block hits the spring is, okay, there is no friction on the inclined plane between the block and the inclined plane. So it smoothly rides down, and over here there is friction, okay. On this part of the ground there is friction, and the friction coefficient is given as 0.5. This length is 2, and after that we have a spring over here. So after the block slides a distance of 2 meters, okay, the spring will start to get compressed. Now the question is, what is the maximum compression in the spring, okay. So what does maximum compression mean? In maximum compression state, if this is, let's say, the spring in the maximum compressed state, okay, what will happen is the block will come to rest over here in the maximum compressed state. So let's say the maximum compression in the spring is x. So how much did the block travel from here to here? So it will include the 2 meter length, right, this 2 meter length plus the additional distance x. This x is the compression in the spring, okay. So this is the initial situation, this is the final situation. Now we conserve energy, right. So from here to here only gravity is doing any work, and what is the work done by gravity? mgh, right. So if this is 10 meters, this length is 10 sine 30, which is 5 meters. So if you do mg into 5, that will give you the decrease in potential energy, right, which is also equal to the increase in kinetic energy. So I mean, we can just conserve energy between the initial and the final state directly, right. So that way the change in kinetic energy is 0. Here also initial velocity is 0, over here also velocity is 0. So delta k is 0. So now we only have work done by friction. We can write work done by friction is equal to change in gravitational potential energy plus change in the spring potential energy, right. Delta k is 0. So work done by friction. So friction does work from, so over here friction acts on the block. So when the block is somewhere over here, friction acts to the left, and what is the force of friction? It is mu mg, right. So for how much distance is friction acting? It is mu mg multiplied with 2 plus x. So friction is acting from 2 plus x in the 2 plus x distance. So work done by friction term, it will be negative. Friction force is mu mg, and the distance for which friction acts is 2 plus x, okay. Delta ug, gravitational potential energy change. So gravitational potential energy decreases, and it decreases by minus mg into 5 meters, right. This is the decrease in gravitational potential energy. And change in spring potential energy, delta u spring, is going to be half kx square. Okay, from here you will get some quadratic in x, and then you can solve to get the answer. The answer will be option 4, I guess. Yes, option 4 will be the answer. Okay, actually there was some mistake in this question. Like in the original NTA key, the actual answer will be some 2.36 or something. You guys can recheck it, but the conceptual idea is more important. Friction acts for 2 plus x distance. So work done by friction is minus mu mg into 2 plus x, work done by any constant force, right? Change in gravitational potential energy is minus mgh. Delta U spring is half kx square. Okay. Potential energy is given as a function of a particle. So this is the function. So this U function has a term in x, term in y, and term in z. Okay, so the force expression will have some I cap component, j cap component, and z cap component. Okay, and how do we find this? By using partial differentiation. The x component of the force is minus dou u by dou x. The y component minus dou u by dou y, and the z component is minus dou u by dou z. Okay. The question is, what is the x component of the force? So we only need the x component. So partially differentiating this with respect to x, so these two terms will just be 0. We treat y and z as constant while partially differentiating with x. So derivative of 2x square is 4x. So this will be minus 4x. The coordinate of the point at which we need the force is 1, 2, 3. So we'll put x equal to 1 here. So the force at that location, the x component will be minus 4 I cap, and the magnitude is going to be 4 Newton. Okay. Yes, 4. Next question, small bob of mass A, m. So these are not like large balls. This is like, you can treat it like a particle itself. Okay. Mass m is attached to a massless rigid rod. So this is a massless rod. At distance 1 meter below the point P. Okay, so basically this will go down and collide with that mass. Then the second mass just manages to complete the circular path of radius r up to a point Q after being elastically hit by a bob A. So there is elastic collision happening. So firstly, once we release this and before this ball comes to the ground, we can find out this velocity, right? Firstly, these are small balls, so the situation is something like this. This ball is over there, the second ball at rest, and this is the first ball. So when this ball reaches the vertical position, we can find out its velocity by energy conservation, right? So this angle is 60, this angle is 60, this is 1, this is also 1. So this height is 1 cos 60, which is half meters. This total vertical line is half meter, so this distance is also half meter. Okay, so which means this ball fell down by half a meter. So we can write down v square is equal to 2gh. This is energy conservation expression from this point to this point. So v will turn out to be square root of 2 into 10 into height fallen. Height fallen is half meters. So the answer is root 10 meters per second. Okay. So now the two balls will collide with each other. This is the first ball attached to that massless rod. And this guy has a velocity of square root 10 meters per second. Now when elastic collision is happening between two balls of the same mass, then their velocities are exchanged. So this root 10 collides with the second mass, and this guy will get a root 10 meters per second, and this guy will come to rest. Okay, this is what happens after the elastic collision. So now this ball starts moving with square root 10 meters per second to the right. Okay, there is no friction anywhere here. So now it's circular motion. We need to find out what is the radius. So yeah, it's given that this mass barely completes the circular motion. So let's see. So the circular motion, we have some particle over here. This had some initial velocity. This we found out it is root 10 meters per second. Okay. So now this particle continues along the circular trajectory and it reaches the top. Okay. and it barely completes the circular motion. Okay, so we need to find the minimum condition. So let's say it had some velocity v. What are the forces? There will be normal force from the track and the weight of the ball mg, right? This is the net force. What is the acceleration? It's the centripetal acceleration, which is v square, v at the top square divided by r. This is the centripetal acceleration. So net force equals mass times centripetal acceleration. Okay. Now in the minimum case, the normal at the top just barely becomes 0. Okay. We'll set normal to be approximately 0, but actually normal is slightly positive. Okay. Which means v square, from here we get it as rg. Okay, so if the ball barely completes the circular motion, then the velocity at the top point is square root of rg. Okay, now we know velocity at the top, we know velocity at the bottom, we can use energy conservation. So energy conservation equation is v square equals u square plus 2gh. Okay, so u square is 10, v square is rg. So v square is r into g, u square is 10. No, it will be u square minus 2gh, right? V square is equal to u square minus 2gh. So v square is r into 10. U square is 10 minus 2 into 10 into height. What is the height difference? It is equal to 2 times the radius. So if we have not made any mistakes, this should be the answer. 4r plus r is 5r, 5r is equal to 1 and r is equal to 1 by 5 meters. Okay. Okay, so yeah, that is the answer. 50r is equal to 10, so r will be 1 by 5, right Ichigo? Yeah, 50r is equal to 10, yeah. Wait, we do energy conservation twice. Yeah, for the first part and for the second part, yes. All right. Position vector r is given. So it changes sign as minus r vector. Okay, so now there is a second case in which the new position vector, let's call it r dash vector, is minus r vector. So in this case, which of the following won't have a sign change, will not flip under sign change? Okay, so basically we have to check these options independently. First, let's do the velocity. So if for the velocity, we will differentiate the position vector, right? So in this case, the velocity vector will be minus dr vector by dt. This is actually minus v vector. So it's sign flipped. So velocity is not the answer. Linear momentum is just mass times velocity. So this will also flip, which means this is also not the answer. For acceleration, we will differentiate this once more. So the new acceleration is, once again, there will be a negative sign, right? So this is also minus a vector. So the acceleration sign also flipped. Angular momentum is going to be the answer, because in the angular momentum term, there is going to be a position vector term and a velocity term, right? So there is a minus here and a minus here. So minus minus would become plus. So there won't be a sign change for angular momentum. Okay, so that is it. Yes, angular momentum is the answer. This is another rotation problem. Bar, so this bar does not have any width dimension. It's like, this is actually negligible, okay? Even though they didn't mention it, it's like the thin slender rod. And it's a smooth horizontal table, so everything is happening in a table surface. 2 point masses m and 2m are moving in the opposite direction with the same speed of v. So this 2m is coming along this line with speed v, and this m is coming along this line with a speed v, and this dotted line is the center of the rod. Okay, so the first 2m mass is from 2 centimeter from the center of this rod, and the m mass is at a distance of 4 centimeter from the center of the rod. These masses strike the rod and it gets stuck to it. Okay, so once they hit the rod simultaneously, it sticks to the rod and they will together move as a single system. The question is, what is the ratio of v and omega? So v is this speed only, not the center of mass velocity. V is this speed, and omega is the angular velocity of the system after these two masses collide. Okay, so let's just redraw the diagram. This is the rod. This is the center of mass line. The 2m mass is coming from some point over here, 2m point mass. It is moving down with a velocity v, and this distance is 2 centimeters, and the m mass is coming from this line, same velocity v, but this distance is 4 centimeters. Okay, and now they will collide, stick to each other, and the system will have a counterclockwise angular velocity. That angular velocity is what we have to find. So the main idea is angular momentum conservation itself. Bar mass 20, oh yeah, that is also important. The mass of the bar is 20 m. Yes, but the interesting idea here is where the center of mass of the system is. So once so this is the before situation, and the after situation. In the after situation, the m mass is over here, 2m mass is over here. Now the thing is, even in this case, the center of mass of the combined system is at the center of mass of the rod, right? The center of mass of the rod is on this red dotted line over here. But if you observe, even after the introduction of this 2m mass and this m mass, the center of mass is at the center of the rod itself. Why? Because this distance is 2 centimeter, this distance is 4 centimeter. So if I take this center as the origin, m1 r1 minus this mass is 2m into this 2 centimeter, right? These two cancel out. If m1 r1 is equal to m2 r2, then the center of mass is at the origin itself. Okay, so because of that, we can conserve angular momentum about this point, which is the center of the rod, but this is also the center of mass of the system. Okay, that's how the 2m and mass are beautifully situated in this question. So now it's just conserving angular momentum, the standard case, right? This question is just an illustration for angular momentum conservation. So Li, Lf, we'll equate them. So angular momentum in the first case. So in the first case, rod is at rest, so there is no contribution. Now this V is coming down, this perpendicular distance is 2 centimeter. This is the center of mass. So we'll conserve it about this point. So mv into perpendicular distance, right? So it will be m 2m into v into 2 centimeters. So I am writing this distance in centimeters itself, and the sense is in the counterclockwise sense. So angular momentum is out of the page. Similarly for this also, the angular momentum is out of the page. And the magnitude is mv into 4. So plus mv into 4. This is I am putting here centimeters itself. So 4 plus 4 is 8 mv. Okay. Now let's talk about the final case. Now in the final case, the center of mass will have some velocity. Let's say in the downward direction. This is velocity of the center of mass, and it will have some counterclockwise angular velocity. So in the final case, because we are writing the angular momentum about the center of mass, we will only have the term I omega. Okay, this is simply going to be I omega, where I is the angular momentum of this system. Okay, so let's find I. So I is going to be, of the rod it is m length square. So the length of the rod is 12 centimeter. So 12 square is 144 ml square divided by 12 plus 2m into distance squared. So 2m into 4, 2m into 2 square plus m into 4 square, 16. So this cancels out 12, 240 plus 8 plus 16. So 264, I guess, 264 m. This is the final angular momentum, this is the initial angular momentum. So 8 mv is equal to 264 m. I guess there was an omega here as well. This is I, we have to multiply with omega. The question was, what was v by omega, I guess? 33. Okay. All right, next problem. Thin circular disk of mass m and radius r is rotating in a horizontal plane about an axis passing through its center and perpendicular to its plane. So this is the disk, this is the axis, and now another disk of same dimensions and mass m by 2 is placed on the first disk coaxially. Okay, so we place another disk. So this is, let's say, the first one. This is the rotating disk. We place a second disk whose radius is the same, but its mass is m by 2 on top of the first disk. Then the question is, what is the new angular velocity of the system? Okay, so this is also angular momentum conservation case, right? Because when we place, so this is, let's say, the second disk and this is the first disk. So because the first disk is rotating and the second disk, when we place it on top of the first disk, there will be friction from the first disk acting on the second disk and vice versa. That friction will be an internal force, right? That friction force will be an internal force which acts between these two disks. Okay, and because of those frictions there will be internal torques. Okay, the torque, so this first disk will exert a torque on the second disk, and because of Newton's third law, the second disk will exert a torque of minus tau on the first disk. So the net torque will be 0. Okay, and when the net torque is 0, we can conserve angular momentum of the system. Most of you guys have done this illustration as well, right? The example where we place one disk on top of a rotating disk. So initial angular momentum, firstly we have a disk rotating with omega. So initially it was I omega, so mr square by 2 omega. Finally we have two disks on top of each other rotating with the same angular velocity. So this is disk 1, this is disk 2, and they are rotating with some final angular velocity omega f. Both of them have the same radius. One has mass m and the other has mass m by 2. Okay, so there we'll add their moment of inertias. So mr square by 2 plus mr square, m by 2 r square by 2, so mr square by 4. This is the net moment of inertia times the final omega. So this will be 3 by 2, no 3 by 4, so 2 by 3 omega, right? Option D, fourth option. All right, so another angular momentum conservation example. So this question is also a repeating question. Somebody else asked me earlier for repeating questions in April shifts. This is also being asked in every shift practically. This is the Young's modulus formula, right? Sigma by A, sigma by strain. Strain is delta L by L. Okay, and here sigma is the stress, F by A. And then you have to take the ratio. Lakshya batch would be taken by Sumit sir. I'll be taking Arjuna. Okay, so this question is being repeated. So just remember this formula. So yeah, here the thing is stretched by same magnitude under a given load. So here F and delta L are same. You just have to take the ratio of area and length basically. Okay, so I'm leaving this question. After reading the PDF, you can see the answer over here. Okay, and you can match your answers after solving. Fluid dynamics. Water flows through a horizontal tube. This is an April problem itself. The difference in height between the water columns in the vertical tubes is 5 centimeter. Okay, so this, the height difference between this point and this point is 5 centimeter. Okay, so just imagine the water is present till here. Okay, and cross-sectional area of A and B are 6 and 3 centimeter square. The flow rate is what they are asking, the volume flow rate, right? dV by dt of this flow, liquid flow. So in fluid dynamics problems, typically we work with Bernoulli's theorem and continuity equation, right? So because there is a cross-sectional area difference, so at this cross-section, the area of cross-section is 6 centimeter square, and over here the area of cross-section is 3 centimeter square. So we know A into V will be a constant, right? This is the continuity equation. Directly a result of mass conservation. So here if I say the velocity of fluid flow is V, V into 3 will be velocity here into 6. So I should say the velocity here is V. So here the velocity will be 2V. Okay, 2V into 3 is equal to V into 6. So that's the first thing. Using continuity equation, we can get the velocity ratio. Okay, and next is we can use Bernoulli's theorem. We need one more equation. So we will apply Bernoulli's theorem between one point over here. One point we'll take it over here, and a second point we'll take it at the same horizontal level, somewhere over here. Okay, so we'll apply Bernoulli's theorem between this first point and the second point. This point we'll call it as A, this point we'll call it as B. So PA plus half rho VA square, PA plus half rho, velocity at A is V, so V square equals PB plus half rho into 2V square. Okay, there is no rho GH term because it's in the same horizontal level. So from here PA minus PB is equal to half rho into 3V square. So now we need PA minus PB, that we can get using this information. So if this height is HA and if this height is HB, I can write PA as P naught, the atmospheric pressure here outside, plus rho g HA, and PB I can write it as P naught plus rho g HB. So from here we can get PA minus PB is rho g HA minus HB. Right, so this will be rho g delta H, and the delta H is 5 centimeters. So rho cancels out. So now we know G delta H, we can find out V. Okay, so solve for V. Once we get the velocity of flow here, the volumetric flow rate dV by dt, we also call it Q sometimes. This is nothing but the area of this cross-sectional area, which is A, which is actually 6 centimeter square, right? Multiplied by V, okay, whatever that V will be, which you get from the equation over there. A into V will give us the volumetric flow rate, okay. Rho AB will give us the mass flow rate. If dm by dt was asked, this will be rho AB. Density multiplied with the volumetric flow rate, okay. Next question, answer will be fourth option, 200 root 3, okay. So this question is also repeating constantly, the surface energy problem, the work done or the surface energy released when two drops combine or when we split drops into smaller drops, right. So here this concept is simple, the energy released, so we will initially have like two water drops, both of them have the same radius r, and they combine to form a bigger drop, okay. So there will be some initial surface energy, and in the final case write down the surface energy, final surface energy, and there will be some energy released, okay. This energy released is what we have to find in this case. Surface energy is very easy, it is surface tension T times the surface area. So there are two surfaces here, so we'll multiply with 2. Surface area of one sphere is 4 pi r square, okay, this is the initial. In the final case, let's say this radius is r, so surface tension times 4 pi capital R squared plus the energy released, okay. So now all we have to do is find capital R using volume conservation. So 2 times 4 by 3 small r cube is initial volume equals 4 by 3 pi capital R cube is final volume. From here you get capital R as cube root of 2 times small r, okay. So now we just have to put it there. The answer will come out to be, I guess, this one, okay. Yes, option 3. Thermodynamics. Okay, so here in this question, we have to find the heat involved in the process from P1 to P2. Okay, so in this process. So what is this process? It's a constant volume process, which is an isochoric process. So from 1 to 2, this is an isochoric process. Okay. We need to find the heat transfer in this case. So Q is delta U, because work is 0 in that case. In isochoric process, work done is 0. So we just have to find delta U. Delta U is number of moles Cv delta T, which is T2 minus T1. What is given to us is P1 and P2. So we can use the ideal gas equation. So because this is a constant volume process, well, firstly we can say delta PV equals delta of nRT. And because it's constant volume, we can take it out. V delta P equals nR delta T. From here we can write delta T as V delta P divided by nR. So this we can write it as V delta P divided by nR. Cv is given to be 21 SI units itself. Volume in this state is 1 meter cube. So V is 1. Pressure difference is 30 minus 21.7, which is 8.3. Once again in Pascal, so SI unit itself. And R is also given in 8.3 SI unit. So answer will be 21. Okay, 21 joules. Okay. Next question. Ideal diatomic gas expands from V to 2V isothermally. Okay, the temperature is given 300 Kelvin and it does W joule of work. Okay, W we can instantly write. It is number of moles, R, temperature, ln V2 by V1. So ln2. This is W. Okay. If the gas undergoes same magnitude of expansion adiabatically from 300 Kelvin, doing the same amount of work W, then its final temperature will be, okay. So, and we need it in degrees Celsius. So, in adiabatic process, the work done, this formula is important. It is nR delta T upon 1 minus gamma, okay. Or, and here delta T is going to be T2 minus T1, final temperature minus initial temperature. Now, initial temperature is 300 Kelvin for the adiabatic process. Let's write it as delta T itself, okay. This work is same as this work, okay. 300 R ln 2 is equal to, number of moles is 1 R into delta T divided by 1 minus gamma. 1 minus gamma is, so the diatomic, it's a diatomic gas, so gamma value will be 7 by 5 for a diatomic gas. So 1 minus 7 by 5 is minus 2 by 5, okay. So from here delta T will turn out to be negative, okay, and then you will write delta T as final temperature minus initial temperature, which was 300 Kelvin. Or what you can do is you can solve delta T, right, and once you get that value you can subtract it from 27 degrees Celsius, okay, that will give you the answer, okay. So this formula you should remember, nR delta T upon 1 minus gamma, okay. Monatomic gas is given, it is stored in a thermally insulated container and the gas is suddenly compressed. So whenever you see the term suddenly compressed or suddenly expanded, usually that is an indication for the process being adiabatic process, okay, because when we have a sudden compression or when we have a sudden compression in the during the process, the time taken to like compress the gas, let's call it dt, this is a very small time, right. So within this time there is not enough time for heat transfer to take place, okay. So that is the significance of the process being done suddenly. So usually in the question they will just mention the process happened suddenly, either compression or expansion. It's an indication for using adiabatic process, okay. But in this question they have also mentioned it is thermally insulated, which by definition just means Q is 0 or heat transfer is 0, okay. Thermally insulated container just means there is no heat transfer happening. So this process is just adiabatic. So you need to use the adiabatic equations, okay. PV power gamma is constant. It's given that final volume is 1/8 of the initial volume. So we know V2 by V1. We need to find ratio of final pressure and initial pressure. So just use PV power gamma equal to constant. That will give you the answer, okay. Gamma value will be 5 by 3 because monoatomic gas. The specific heat at constant pressure of a real gas obeying PV square equals RT. Okay, so here N is equal to 1. So the important thing here is that this is a real gas, not an ideal gas. Okay, so this gas does not follow the ideal gas state equation. That is the only important thing here. So specific heat at constant pressure. So Q, because this is a process happening in constant pressure, right? Q we can write it as Cp delta T, Cp dt. Number of moles is 1 by looking at this relation, right? If number of moles is n, we would include nRT. So n Cp dt, n is going to be 1, and because the process is happening in constant pressure, Q we can write it as Cp dt. Now this is equal to, Q is du plus dw, so this is dq. dq equals du plus w. First law, right? This is equal to du plus dw. du is going to be Cv dt. Work done is PdV, right? So far we didn't use anything related to ideal gases. Now the thing is, we cannot replace like P with the ideal gas equation. We need to use this relation. Okay, we need to figure out what is P dV. We need to express dV in terms of dt so that we can cancel out dt from both sides. So for that we'll use this relation. So first things first, pressure is constant, right? So to find out dV, I have to differentiate this. So pressure is constant, so we can take it out. Derivative of V square is 2V dV equals R times derivative of T is dt. So from here we get P times dV equals R dt divided by 2V. So this we can write it as R dt divided by 2V. Okay. Now in the ideal gas case, what we did was we used the ideal gas equation to replace this PdV, right? Here we will use the given equation. That is the only difference, and now we will cancel out dt's, and the Cp value is what they asked, that is going to be Cv plus R divided by 2V. Okay, so third option. SHM amplitude is given A, distance from mean position where its kinetic energy becomes equal to the potential energy. Okay, so you can think of the spring mass case or just the simple x equals A sin omega t. Okay, so here this is the mean position where elongation or compression in the spring is 0, and this distance x is what is given to us by this equation. Okay, so the kinetic energy and the potential energy of the particle is the same. Potential energy we can write it as half kx square, x elongation in the spring, x is going to be A sin omega t square. This is equal to the kinetic energy, which is half mv square, and v we can get by differentiating this. So differentiating will be A omega cos omega t whole square. These two must be equal. Now omega we can write it as square root of k by m. So omega square will be k divided by m. So this will become half k A square sin square omega t, and this will become half. So omega square is k by m, m cancels out. So this is also half k A square cos square omega t. So this constant cancels out, and we get sin square omega t is cos square omega t. So you can take tan theta equals 1. So basically sin omega t, that is 45 degree, right? So sin omega t will be 1 by root 2. Now the question is, what is the x coordinate? So if you put sin omega t as 1 by root 2, the x coordinate at that location is a by root 2. Okay, so first option. So a by root 2 is where this and this become equal, that is kinetic energy and potential energy. Next question. So, time period of oscillation of a simple pendulum of length L suspended from the roof of a vehicle, which moves without friction down an inclined plane of inclination alpha. Okay, so we have an inclined plane, and the car, we can just draw it like a box. So first things first, this box, the acceleration of this box is going to be g sine theta, right? Simple F equal to ma, there is no friction on the box, so the acceleration of the box is g sine theta. Now the thing is, we will draw the picture happening inside the box. So let's say I draw it like this in the horizontal way. So this acceleration is g sine theta. Okay, so if I, let's say, hang some mass from the roof of this box, there will be mg cos theta downwards. Okay, why is it mg cos theta downwards? Because this is the situation from this view, right? So in this direction we have mg cos theta, and in this direction we have mg sin theta. So on this ball we have mg sin theta to the right. This is the mg force resolved along down and right direction, which in that view is along this direction and this direction. So now the thing is, we will work in the frame of this car. Okay, so our observer is somebody standing inside this car. Okay, now this observer is in an accelerating frame. So we learn in Newton's laws, whenever we work with accelerating frames, if this observer needs to apply F equal to ma on this mass, we have to apply pseudo force, right? And what is the acceleration of the frame? G sine theta. So pseudo force on this ball is minus m into g sine theta, so which is towards the left. So these two cancel out, which means the only force, extra force, is going to be mg cos theta. Okay, so basically, to summarize everything, on this ball we will simply have a force of mg cos theta. Okay, now this is similar to the simple pendulum case which we are used to. So in this case the net force was mg, right, where we have a ball just simply hung from a roof. In this case the time period was 2 pi square root L by g. Now this is kind of like a world where gravity is g cos theta. So the only difference is, instead of g here it will be g cos theta, which means it will be option 1. Okay. Okay. Now particle executes SHM, nature of graph of velocity versus displacement. This is a formula that we cover in SHM. So that is V square, V equals omega under root of a square minus x square. Okay, they're asking what is the relation between V and x. So V square by omega square equals a square minus x square. So V square by omega square plus x square equals a square. So now if you divide with a square, this will be an ellipse, right? So divide with a square on both sides. This is similar to y square, x square by a square plus y square by b square equals 1. So this relation between v and x will be elliptical. Okay. Velocity of sound in air is doubled when the temperature, this is another formula based one. Velocity of sound in air is square root of gamma RT divided by m. So the main idea is it's proportional to root of temperature, okay, and the temperature is in Kelvin. So if I want to double the temperature in kelvins, the temperature needs to be made 4 times. So initial temperature is 273 Kelvin, final temperature is 4 times that. Now we want the answer in degree Celsius. So all you have to do is from this value subtract 273. That will give you the answer. Okay. The answer will be 819. This question is also repeating constantly, where we have the equation of a traveling wave and they are asking the speed of the wave. Okay, so this formula is just straightforward. It is omega by k. Omega is the coefficient of this t inside the sine function, and k is the coefficient of x inside the sine function. So this is going to be 320. So x and x is in meters, so this is in meters per second, but the answer they want it in kilometer per hour. So just multiply with 18 by 5 and you'll get the answer in kmph. Okay, so the answer is 1152. This will be 1152 kmph. Organ pipe 40 centimeter long is open at both ends. So open organ pipe, just remember the fundamental frequency case, right? So the diagram of the standing wave pattern will look something like this. So the length of the pipe L is equal to lambda by 2. So the wavelength of the standing wave is 2L. Okay. So using this you can write the fundamental frequency as the speed of the sound wave divided by lambda. Now the question is second harmonic. That's what we have to find. Second harmonic is simply 2 times the fundamental frequency, which is V divided by L. V is given to be 360. Length is 0.4 meters. This will give you the answer. Okay. Two planets A and B having masses m1 and m2 move around the sun in circular orbits of r1 and r2. The angular momentum of A is L and that of B is 3L. Time period Ta by Tb is, okay. So we have a sun at the center and two planets in circular orbits. So this is R1, this is R2. Their masses are also different. So basically M1, M1 R1, so I'm taking its velocity as V1. So M1 R1 V1 divided by M2 R2 V2. This is their angular momentum ratio. This is given to be 1:3. Okay. Now the time period ratio is what they are asking. So time period ratio is, we can use the Kepler's relation. T square proportional to R cube. So with that, T1 by T2 is equal to R1 by R2 whole to the power 3 by 2. Okay. So we need R1 by R2. Now what about velocities? Velocity ratio. This is V1, this is V2. The orbital velocity has a formula, as a formula is derived in class. So the orbital velocity is square root of gm divided by r, where m is the mass of the sun. So m1 by m2, r1 by r2. So v1 by v2 will be square root of r2 by r1. So this is square root of r2 by r1, and this is equal to 1 by 3. Okay, so from here you can get, so this will be root of r1 by r2. So from here you can get r1 by r2 and you can just put it over here. That will give you the answer. Okay, so the answer will be option 4, 1 by 27 m2 by m1 the whole cube. Okay, 4 identical particles of mass m are placed at 4 corners of the square. If the gravitational force exerted on one of the masses by the other masses is, so we need to find the net force on one particle. We have 4 particles placed at the corners of a square. Okay, so if I pick the particle on the right corner, this particle will attract this one, this particle will attract it in this direction. These two forces, let's call it as F. If the side length of the square is A, then F is simply gm square by A square. Okay, the third mass will attract the particle in this direction. Okay, and this force has a magnitude of, let's call it F dash. F dash is gm square by root 2a the whole square, so this will be 2a square. So this is in fact F by 2. Okay, so what is the net force? It is the sum of these 3 vectors. So F and F perpendicular to each other, the net force is along this direction itself, right? So F and F, angle between them is 90, so the net force is F root 2. Okay, so the net force is going to be this F root 2 plus this F dash. So F net is F root 2 plus F by 2. So this is F, which is gm square by A square, times root 2 plus half, which is 2 root 2 plus 1 divided by 2. So now you equate this to this, and I guess you will get A square as 16L square, or A is equal to 4L. Okay, so yeah, that is it. At what distance above and below the surface of the earth a body will have same weight? So we need to talk about the value of G. So if you have a point which is a distance, let's say d above the surface of the earth, the G at that location is given to us as G at the surface times r square upon r plus d the whole square, right? And if you have a point which is at a depth d from the surface of the earth, the G value is given as G at the surface times 1 minus d by r. Okay, so inside the earth, G value drops linearly as you go closer and closer to the center, and as you move away from the surface of the earth, it varies as 1 by r square. Okay, so basically you just have to equate these two and there will be a quadratic forming, and you just need to solve for d and the answer will turn out to be third option. Okay, all right. Next question, two particles of mass m go around a circle of radius a under the action of their mutual gravitational attraction. The angular speed of each particle is. So this is a binary star problem. So we have two stars that are moving in a circle. So this is star 1, this is another star. So this star has a velocity, let's say v. This star will also have velocity v, and they are moving in this circular path. This is their center of mass. Okay, so we need to find the omega, angular speed. So like this particle will have some angular velocity in this circular motion. We need to find that omega. Okay, so first things first, these are two masses of mass m. So there will be a gravitational force of attraction. So on this particle, the gravitational force of attraction is gm square divided by r square. So distance between them is 2a. So 2a the whole square is 4a square. This is the force of gravity being exerted on the first star. Now this force of gravity is what provides the centripetal acceleration, and the centripetal acceleration, because we want the omega, we will write the centripetal acceleration as omega square a, omega square times this radius. So now we can use F equal to ma, gm square by r square. F net equals mass times acceleration. So from here we get fourth option as omega. Okay, so first is, this is just applying F equal to ma, and here the acceleration is omega square a, circular motion idea. Force is the gravitational force. Okay, that is the only idea. All right. Next, electrostatic potential in a charged spherical region of radius r varies as ar cube plus b. Okay, so basically at a general location whose radius is r, the potential is given ar cube plus b. Okay, now we need to find the total charge in the sphere of unit radius. So firstly, if I am given the potential, the way to find the electric field, so in this case the electric field will be firstly radial, because the potential only depends on r. So this is given to us by minus dV by dr. Okay, similar to finding the force from the potential energy function. So E is minus dV by dr, so this is minus 3a r square, and of course the electric field will be in the radial direction. So what that means is, if I choose a point somewhere over here, at a radial distance of r, the electric field will be in the minus r direction, which is in this direction, opposite to r vector. So now once we know the electric field, if we want to relate it to the charge, we can use Gauss law, right? So using Gauss law, we can say the flux of electric field, the net electric flux, equals the enclosed charge divided by epsilon naught. You can use Gauss law in this spherical surface. They want the total charge in a unit sphere, which is r equals 1. So electric field for a sphere whose radius is 1 is minus 3a, right, r cap. And what does this mean? The flux calculation will be easy in this case, because if I choose a tiny area somewhere on the sphere, here the electric field area vector is in this direction along the normal direction, and the electric field is in this direction, right? And area vector n cap is in this direction, dA vector. So if I want to do E dot dA everywhere on the sphere, dA vector and E vector are opposite to each other. So integral E dot dA will be just integral of minus E dA, E into dA. Okay, the dot product can be easily removed. Now what is this E? E is nothing but 3A because R is equal to 1. dA is going to be 4 pi, I mean because electric field is constant, we can take it out, right? So minus 3A times integral dA is the total surface area of the sphere. Because the radius is 1, it is 4 pi. 4 pi into 1 square. This is the net electric flux. This is equal to the net enclosed charge divided by epsilon naught. So net electric charge is minus 4 pi A epsilon naught. Minus 12 pi A epsilon naught. So the answer will be minus 12. Okay. All right. So this is application of Gauss law and finding the electric field from the potential. So this is the potential, the net potential, and we have finding problem, and we have 3 conducting spherical shells. A, B and C, radius of them are small a, small b, small c. C is the largest, then B, then A. Charges are Q1, Q2, Q3. We need to find the potentials of sphere A, B and C, okay, on their surface. So sphere 1 is the other next sphere, third one. Okay, this sphere has charge Q1, next one Q2, the next one Q3. Okay, so first we'll write down the potential at the surface of this sphere, the innermost one. Okay, so the idea is simple. We will individually write down the contributions due to Q1 sphere, Q2 sphere and Q3 sphere. Okay, now due to Q1 sphere, the electric potential at its surface is, so if this radius is A, it will be KQ1. So let's call this V1 first. V at the surface of, so innermost sphere is A, so let's call it VA. So potential at the surface of A. So first we'll include just the contribution due to Q1. So it will be KQ1 by A. Okay. Now due to sphere Q2, this particular point at which we want the potential, this point is inside sphere Q2, and inside the sphere Q2 everywhere the potential is same and it is equal to the potential at the surface of Q2. Okay, the potential at the surface of Q2 is KQ2 divided by B. B is the radius of sphere Q2. Similarly, this point is also inside the sphere Q3, and inside the sphere Q3 everywhere the potential is same and it is equal to the potential at the surface of Q3, which is KQ3 divided by C. So this is the potential of the shell A at the surface of shell A. So now at the surface of shell B over here, now once again we'll use the same logic. Due to Q1, this is an external point, so we will write the potential as KQ1 by, what is the distance? B. So B. Now due to Q2, of course it is at the surface, so it is just KQ2 by B. Now due to Q3, this is an internal point, so once again everywhere inside the potential is KQ3 by C. Okay, so now what's left is the outermost shell. So over there, no, this was VB, the last is VC, and this point is external to shell 1, so KQ1 by C. It's external to shell 2 as well, so it will be KQ2 by C, and it's on the surface of Q3, so KQ3 by C. That's how we write the potentials. We individually look at each shell one by one, and depending upon if it's an internal point or external point to the sphere, the formulas will vary. Okay, if the point is outside the shell and this distance is R, then the contribution, if this is Q, is going to be KQ by R. if the point is somewhere inside the shell and the radius of the shell is small r or capital R, then the potential everywhere inside is kq divided by radius, which is capital R. Okay, that's the logic we used here. Here the only difference is we individually added their contributions one by one. Okay, potential is a scalar, so it adds up like mass. Okay, so the answer will be the last option, I guess, fourth option. Okay. Next, so this is a flux problem. This is a standard illustration. We can quickly do it. So what is the flux through this cube due to a 2q placed at the corner and a q placed at the center of a face, right? Now, due to the charge present at the center of a face, you must have done this problem. Half the field lines passes through the cube, right? So due to this q, the net flux contribution is, total flux of this q is q by epsilon naught. Half of the total flux passes through the cube. Okay, half of the field lines pass through the cube. And similarly, we have a 2q placed at the corner, and due to this 2q, 1 by 8th of the total field lines pass through this cube. Okay, so number of field lines passing through this cube is 1 by 8th of the total flux. So due to the 2q, it is 1 by 8 times total flux, which is 2q by epsilon naught. Okay, so due to the charges sitting at the corner, the total flux is 1/8 of the total flux. Due to the ones sitting at the center of face, it will be half of it. Okay, so how much is this? This is 1/4, this is half, so 3/4 q by epsilon naught. Okay, second option. Next, simple pendulum bob with mass m and charge q. Pendulum string has negligible mass, uniform and horizontal electric field. Okay, uniform electric field is there, it is applied and the tension in the string changes. The final tension in the string when pendulum attains an equilibrium position is, okay. So after the electric field is applied, the bob will shift its position. We need to find the final tension. So let's say the electric field is to the right, so the situation will be something like this. Okay, so on this we'll have two external forces other than tension, the QE force to the right and the mg force in the downward direction. This is QE, this is mg, and we also have the tension force. Now the question is, what is tension? So it's simple, it's if you observe the resultant of the electric field and the mg force, their resultant will be in this direction, anti-parallel to tension. If QE and mg, if you want to write its resultant, because these are at 90 degrees, this will be root of mg whole square plus QE whole square, right? The resultant of QE and mg is going to be root of mg square plus QE square, and this has to be anti-parallel to t, right? Otherwise they cannot cancel out, and once they cancel out, the ball will of course be in equilibrium. The ball is of course in equilibrium, so this force and this force, they cancel out, so tension is equal to this force. Okay, and here it will be 2, I guess. So option B is the answer. Okay, next, this is a net electric field problem. So we have a system in which system of charges are like this. We need to find the net electric field at the center of a circle. Okay, and we have to write it in vector form. So we need to find the electric field here. So these 6 charges are placed at the circumference of a circle. Okay, now due to this plus q and this plus q, they mutually cancel each other off at the center, and due to this plus q and this plus q also, they mutually cancel each other off at the center, their fields will be anti-parallel. So we don't have to look at them. We only have to look at the other two charges, which is this minus q and this plus q. Due to this minus q, there will be a field of kq by r square in this direction. Due to this plus q, there will be a kq by r square in this direction, the same direction. So the E net will be 2kq by radius squared, and it's in this direction. So if this angle is 30, then this angle is also 30. So all we have to do is this net magnitude, we just have to multiply it with the unit vector in this direction. Okay, so how do we find that unit vector? The direction we are looking for is 30 degree along this direction. So we'll take a vector whose magnitude is 1 because we are looking for the unit vector. This angle is 30 degrees. Okay, this angle is 30 degrees. So now we just find its components, right? So the x1 is 1 cos 30, which is just root 3 by 2. The y component is 1 sin 30, which is half. So the unit vector is minus root 3 by 2i plus half j. So to this we'll multiply minus root 3 by 2i plus half j, and this will be the answer. Okay, so if I cancel out the 2, it will be minus q by 4 pi epsilon naught r square minus root 3i minus j. Okay, so option C seems to be the right answer. Okay, that is it. Next, infinitely long wire having uniform linear charge density lambda 2 nanocoulomb per meter. The net flux through a Gaussian cube of side length root 3 centimeters, where the wire passes through any two corners of the cube that are maximally displaced from each other. So the largest diagonal inside a cube is the body diagonal, right, whose length is root 3a. So there is a wire kept in the body diagonal position. So the length of the wire will be root 3a, right, root 3a, which is 3 centimeters. So now the question is, what is the flux? What is the question? Net flux, yeah. So net flux is just enclosed charge by epsilon naught, simple Gauss law. And enclosed charge will be length into lambda. So 2 nanocoulombs into length is 3 centimeters. We'll convert it into meters. This is the enclosed charge divided by epsilon naught. Now the epsilon naught value is not given, so we'll use this. We'll multiply divide with 4 pi. 1 by 4 pi epsilon naught, we will write it as 9 into 10 to the power 9. And this should give us the answer. This cancels out. 4 2s are 8, 24. 24 and 9, so I guess 216 pi divided by 100, so I guess this should be the answer. Yeah, 2.16 pi. Next, consider a parallel plate capacitor of area A, separation D between the plates. E is the electric field and this is epsilon naught. Is the permittivity of free space between the plates, potential energy stored in the capacitors. So this is just to revise the formula. That is, if you have two parallel plate capacitors, of course if D is small as compared to A, the electric field will be like this, electric field pattern, the uniform electric field. This magnitude is given to be E. Now the energy stored in this electric field, we can write it in multiple ways. We can use half CV square and other formulas as well, but we can also use the energy density formula. So the electric field energy density is half epsilon naught E square. Okay. This is the energy per unit volume. So the total energy we can get it by multiplying it with the volume, the total volume, which is this area of cross section multiplied with d. Okay. Now of course we can simply multiply because it's a constant energy density. Electric field is constant, right? If electric field varied with position, then we'll have to integrate it, right? But yeah, this is just constant electric field, so energy density is constant, energy per unit volume is constant, so we'll just have to multiply with the total volume in which electric field is present. That will give us the total energy stored. Okay. Next, this is just standard Gauss law definition. 5 charges are present, we need to find the flux due to this configuration, due to this Gaussian surface. Okay. So that is basically due to the charges present within the surface, right? The electric field due to all these charges, that is the left hand side, basically the net electric flux. This is equal to the charge enclosed within the surface, which is 6 minus 2 4q divided by epsilon naught. Okay. So this is the net electric flux, so D option. Yes, again option 4. Next, equivalent resistance of the circuit. So yeah, here these 3 resistances are in parallel, and you can quickly see it. If this is A and if this is B, this is connected by a connecting wire, so the potential difference is same. If this is B, this will be B as well. If this is A, this will be A as well. Okay, so the potential difference across this resistor is VAB. Here also it is VA minus VB. Here also it is VA minus VB. So these 3 resistors are connected in parallel. Okay, and if they are connected in parallel, we can use the parallel combination formula. So these 3 are equal resistors. So R equivalent is their individual resistance divided by 3. So option 4, R by 9. Yes. Next, another R equivalent finding problem. So here there is symmetry. So if you draw a perpendicular plane to this x direction, you can see that there is left and right mirror symmetry. So basically whenever we have a symmetry line, the potentials of all the points lying on that line is same. So same potential meaning no potential difference in this branch or in this branch, or you can use the current symmetry argument as well, right? So anyways, we have 2R here, 2R here, 2R here as well. So due to this square, basically the equivalent is 2R by 3. Here we have R and R connected in series. They will be in series with this middle thing. So effectively we have a 2R and the middle thing is 2R by 3. So this is going to be 8R by 3. Okay, so that is it. There is no current in these vertical branches. Most people use the current symmetry argument, I dash. So which means no current in the middle one, so you can throw away the middle one. 2R in parallel, effective is 2R by 3. Then we have R and R in series, which is 2R. They are in series together, so 8R by 3 will be the answer. Okay, next question. Water boils in an electric kettle 20 minutes after being switched on using the same main supply. The length of the heating element should be, so we have to fill in the blanks basically. So if I want to boil it in 15 minutes now, so what should be done with the length of the heating element? So length of the heating element, when you modify it, you change the resistance of the boiler basically. Okay, it's similar to the rho L by A, so the resistance increases with length, that idea. Okay, so yeah, so basically, so in the water boiler, basically the heating element, it provides some power. Okay, and this power into time is the total energy supplied to the water, right? And this energy is what boils the water. Now this energy in the initial situation should be equal to the energy in the final situation, right? Because to boil water, the energy that you have to supply is ms delta T, which is the same initially and finally, right? So from here P2 by P1, the second case we are boiling it in 15 minutes, in the first it is boiled in 20 minutes. So this will be 20 by 15 or 4 by 3. So the power extra in the second case, we have to increase the power of the heating element by 4 by 3 times the initial case. Okay, now in case 1 and case 2, of course the supply is the same. So we can write P2 by P1. Now power is V square by R, right? Because the main supply is the same, the voltage across the appliance is the same. So P is V square by R, so this will be V square by R2 divided by V square by R1. So this would become R1 by R2. Okay, and the resistance is directly proportional to the length of this heating element. Okay, so this will be equal to L1 by L2. So this is basically the opposite ratio, I guess. Yeah, this will be L1 by L2. So the length ratio L2 by L1 is 3 by 4. So basically we need to reduce the length by 3 by 4 of the original. Basically the new length should be 3 by 4th of the original length. That way the resistance reduces so that the power, which is V square by R, increases. Okay, so hence the answer is the length should be decreased to 3/4 of the original value. Once again, okay, so basically the energy supplied to the water is the same, because in order to boil water, the energy you need to supply is ms delta T. So that energy initially and finally is the same. Who's providing the energy? The heating element. Okay, so I'm saying in the initial case, if the power of the heating element is P1 and the time, power into time gives us the energy, right? So power P1 into T1 is 20 minutes in the first case, that T1 is equal to the new power into the new time, and the new time of boiling is 15 minutes. So if you want to boil the same amount of water in less time, you need more power, right? That is what this equation is telling us. So the power ratio turns out to be equal to 4 by 3 firstly. Now the power of the heating element, we will write it as V square by resistance of the heating element. Okay, and we are using this formula because V remains the same in both cases, right? The main supply is the same. So the voltage supplied is the same in both cases. That's why we are using this formula. Now using that formula, we are writing it as V square by R2, P2, and P1 we are writing it as V square by R1. So P2 by P1 turns out to be R1 by R2. Okay. Now the thing is, in the case of the heating element, the length of the heating element is proportional to the resistance of the heating element. Okay, this is, you can think of it like the formula which you learned for resistance of a cylindrical conductor, right? Where R was equal to rho L by A. So the greater the length of the heating element, the greater its resistance. So they wanted the length. What happens to the length? That's what they wanted to know. So that's why I had to replace the power ratio to resistance ratio, and the resistance ratio is the same as the length ratio. And using that, finally we compared L1 by L2, it turns out to be 4 by 3, or L2 by L1 is 3 by 4, which means final length is 3/4 of the initial length. Okay, Om. Yeah, no issues, Om. Alright, next question, value of unknown resistance for which potential difference between B and D will be 0. Okay, which is potential difference between this point and this point. So this is essentially just a Wheatstone case, right? In the Wheatstone case, there is a galvanometer in between them, in which case there is no current, right? So which basically means the potential difference between B and D is 0. So here it's the same. So this is just a Wheatstone bridge. So R1 by R2 equals R2 by R1. So equivalent of 1 and 1 in parallel is 0.5. Here also there is 0.5. So 0.5 divided by 0.5 equals, here we have 24 in parallel with another 24. So equivalent is 12. Here we have 12 and 12 in parallel, which is 6 in series with x. So this will be 6 plus x. Okay, so from here x turns out to be 6. Okay, x turns out to be 6. All right. Next, galvanometer of resistance 100 ohm when connected in series with 400 ohm measures a voltage of up to 10 volt. Okay, so initially when it is used as a voltmeter, so this is the galvanometer and its resistance is 100 ohm. It is connected in series with 400 ohm and this is used like a voltmeter. Okay, so of course in the galvanometer branch, for the case of full scale deflection, the current flowing is Ig, right? It's given that it can measure up to 10 volt. So 10 volt is the maximum, right? So this is of course connected in parallel to some resistor, right? And this resistor's max to max, it can measure 10 volt potential difference. So in the maximum voltage case, we want Ig to flow through the galvanometer, because when Ig flows through the galvanometer, it shows full scale deflection. So you must be knowing this. In the galvanometer, its deflection, maximum deflection or deflection in general is proportional to this current. So the greater the current that flows through this galvanometer, the greater will the deflection that it shows. Now Ig is the maximum current which shows which means when Ig flows, galvanometer shows maximum deflection. Okay, and we want this maximum to be 10 volt. Okay, maximum when the galvanometer shows max deflection, we want that to be 10 volt. Okay, so firstly we'll apply Ohm's law here. So Ig into G plus 400. What is G? G is 100. So 100 plus 400 is 500. This should be 10 volt. So from here Ig is 10 by 500. If you multiply with 1000, you'll get the answer in milliamperes. So this is 20 milliamperes. So when 20 milliamperes of current passes through the galvanometer, the needle shows full scale deflection. In the second case, we are asked what is the value of resistance that we need to convert the galvanometer into an ammeter. Okay, so to read up to 10 amperes. So the maximum current that we should be able to measure from the ammeter is 10 amperes. Okay, so in the ammeter case, what happens is so yeah, we want 10 ampere current. Okay, now the thing is, the galvanometer will have G, and in parallel we will connect a shunt resistance. Let's call it S. So why are we connecting in parallel? Because if the total current through the galvanometer, this has to be Ig, right? If a large amount of current passes through the galvanometer, it destroys the galvanometer. So that's why we give the current a different path to move, and that's why the shunt is connected in parallel. So now because Ig was how much? 20 milliampere, right? For full scale deflection, we calculated in the previous 20 milliampere. Now 10 amperes is significantly larger, so we'll just consider this to be approximately 10 itself, even though it's actually 10 minus 20 milliampere, but it's almost 10 itself. Now this galvanometer, whose resistance was 100 ohm, is in parallel with the shunt. So 10 into the shunt resistance is equal to Ig into 100, which is 20 milliampere into 100. 1, 2. So shunt resistance is 0.2 ohms. Okay, and the value of X they wanted in terms of 10 to the power minus 2. So multiply this with 100 and the answer will be 20 ohms. Option B, yes, it's option B. Okay, so that's it. Next, we have a metallic ring. It is placed in a time varying magnetic field. So there will be induced EMF, and because of that induced EMF there will be an induced current, and that current is what we have to find. Okay, so induced EMF, you can find it as, when its magnitude, you can find it as d phi by dt. So what will the flux be? Because the area vector is parallel to the magnetic field, it will simply be b pi r square. Okay, now d phi by dt, you differentiate magnetic field with respect to time, right? And once you put t equal to 2 seconds, you will get the EMF induced at t equal to 2 seconds, and the current is simply by using Ohm's law, EMF divided by resistance. Okay, the answer, yeah, the first option. Okay, next. Electron traveling with velocity v in free space, when it enters a medium, its velocity is reduced by de Broglie wavelength. This is another important formula, pretty much repeated in every shift. Velocity is reduced by 20%, so basically v becomes 0.8 v. Then what happens to the wavelength basically? So de Broglie wavelength is proportional to 1 over v, right? So if velocity becomes 0.8 v, then lambda becomes, so this is like 8 by 10, 5 by 4, which is 1.25. 1.25. Previous question. Yeah, so this is like Faraday's law, right? Induced EMF. So there is a metallic ring. Okay, the area vector is in this direction, let's say. The magnetic field is in this direction. So you can calculate the magnetic flux using B into A, right? Now, once you get the magnetic flux, also notice that it's a time varying magnetic field. So there will be an induced EMF. So that induced EMF you can find by differentiating the magnetic flux. Okay, this will be some function of time basically, because if you do dB by dt, it will be a function of time. Now in that function, if you put time as 2 seconds, right, that's when they want it, you will get the EMF. Okay, now if this is the ring and the EMF is known to you, the resistance is given, then you can apply Ohm's law here, or KVL, right? E equal to IR. So you can get the current. That is the question basically. Okay, Mohammed. So this is 1.25, straightforward formula. Next, YDSC setup slit separation. These are all April shift mains problems. Slit separation is 5 lambda. Screen capital D distance is actually 10 times this slit width, so this is actually 50 lambda. Maximum intensity is I naught. Maximum intensity of the interference pattern, okay, is I naught. Find intensity at point directly in front of one of the slits. So if these are the two slits, okay, and if this is the screen, a point directly in front of the slit, which means somewhere over here, this is the other path. So this length is given to be 5 lambda, this length is given to be 50 lambda. Okay, so we need the path difference between the two distances through which the wave travels, right? So this is the first path, this is the second path. This length we can find using Pythagoras theorem. Now because this is only like 10 times difference, we can't use like approximations here, right? So we will use Pythagoras theorem to find out this distance. So this will be like under root of, we can take lambda outside and 5 outside. So 5 lambda outside under root of 100 plus 1, so 101. This will be the hypotenuse. So the path difference is 5 lambda into root 101, this distance basically, minus this distance, which is 50 lambda. This is the path difference between the two lengths, right? So 5 lambda we can take it out, and inside we have square root 101 minus how much? 10. Okay, so I mean we can also use d sine theta, but I mean now as we started with this method, we'll just solve it using this binomial approximation. So this will be, you guys can also do the d sine theta method, right? Just connect it with the center. Okay, and if this angle is theta, the path difference is d sine theta. Sine theta you can easily write, right? Because this length is 2.5 lambda divided by 50 lambda. With that you can get sine theta. So sine theta is approximately theta, and this is equal to opposite upon adjacent. So it will be, let's see if we can get it using this method. So 2.5 divided by 50. So 1 by 20. Okay, and once we get sine theta, the path difference is d sine theta, which is 5 lambda into sine theta is 1 by 20, which is lambda by 4, and phase difference is k delta x, right? So 2 pi by lambda times lambda by 4, this is 90. So the phase difference between two waves is 90, and then the interference intensity is, max intensity is given to be I naught cos square phase difference divided by 2. Phase difference was 90, 90 by 2 is 45, cos square 45 is half. So this is actually I naught by 2. So actually what I did was, initially I was I found out this distance using Pythagoras. This distance minus this distance is the path difference, and I was going to write the path difference in terms of and then I was going to simplify this using binomial approximation. Okay, but then I realized I can just use the d sine theta formula. Okay, so yeah, I naught by 2. All right, next, this is a lens problem. So this is 10 centimeter. This is a simple problem. I mean, you have to apply lens equation twice. So 1 by v minus 1 by u equals 1 by f. Just have to apply it twice. The answer will come out to be this. Okay. So yeah. So this question is also April shift. Magnetic field at a distance x from point C as shown in the figure on rod is. So B naught e to the power. So the magnetic field as a function of x is B naught e to the power minus lambda x. Okay, if this is x. The induced EMF between the ends of the metallic rod. So here, as the magnetic field is different at different x, what we do is we go a distance of x from the axis, okay, and we take a tiny piece of length dx, right? So this is the first point, and then we move further a distance of dx, and this is the metal piece that we choose. This metal piece is what we choose. Now in that, the magnet, we can consider firstly the velocity. The velocity of this tiny piece, we can write it as omega times x, right? Now we have, most of you must remember this formula. If I have a conductor whose length is L and it is moving V perpendicular to a magnetic field, the EMF induced is BVL, motional EMF example, right? And this also we can consider it like that. This is a metal current carrying not current carrying, metal piece. It is moving with velocity v omega x in a magnetic field which is perpendicular. Okay, so if you do v, which is upwards, cross b, let's say the magnetic field is out of the page, so if you do v cross b, the right direction gives us the positive terminal and this is the negative. Okay, so this is a tiny, you can treat this like a tiny induced battery, something like this. Okay, and this tiny induced EMF, the formula is BVL, which is magnetic field. And what is this magnetic field? It's the magnetic field at this location, which is B as a function of x, right? This is actually B naught e to the power minus lambda x. This is the magnetic field at x. Velocity of this piece is omega x into the length of this conductor, and the length of the conductor is dx. This is the induced EMF on this tiny metal over there. Now the thing is, we will integrate this, and through integration we will cover all these metal pieces and add up their individual EMFs through integration. So all we have to do is just integrate this. Now the thing is, this is a integral which involves x e to the power minus lambda x. For this you have to use by parts. Okay, take the exponential as the second function. I will drink some water. Okay, so I'll explain the galvanometer question. I am skipping the integration. You guys just have to take this as first function, this as second function, integrate it from x equal to 0 to x equal to L. You'll get the total EMF. Okay, and I guess the answer is first option. Okay, if the memory based question is correct, but this question is anyway covered in class for a constant magnetic field. Okay, so let's look at the galvanometer question once again. So in the galvanometer question, in the first case, we are considering it as a voltmeter, right? So voltmeter, when we have an external resistance, we connect the voltmeter in parallel to the external resistance, right? So we want the maximum voltage that the voltmeter calculates to be 10 volt. That is what they have given. Okay, now the voltmeter, it is basically this galvanometer plus an additional 400 ohm resistor, right? Now through the galvanometer branch, we cannot let more than Ig current pass. This Ig is the current at which the galvanometer coil, if you think of this like an arrow, if Ig passes through this galvanometer, it shows full scale deflection, max deflection. Okay, so Ig is the maximum current that can pass through the galvanometer. If a lot of current passes through this galvanometer, it will break it. Okay, so Ig passes through this galvanometer. It is the full scale deflection current. Now we want this galvanometer at its full scale deflection to show the maximum voltage, right? And the maximum voltage is 10 volt. So when Ig passes through this galvanometer, the voltage across the terminals should be 10 volt. Okay, that's why I wrote Ig into total resistance, which is, so this G has a resistance of 100 and the extra resistance has 400 ohms. Okay, it is connected in series with 400. So net resistance is 500 into Ig should be 10 volt. Okay, using that we get Ig. Now in the second case we have ammeter. In the ammeter case, this is how the shunt extra resistance is connected. We connect the shunt resistance in parallel to the ammeter. Okay, now the 400 resistance is gone. We connect this resistance in parallel to the galvanometer. Now once again, we cannot let more than Ig pass through the galvanometer branch. Okay, so Ig, which was 20 milliamperes, still passes through the galvanometer. Okay, but in this case, this is the ammeter. The maximum reading of the ammeter should be 10 ampere. So a total current of 10 amperes flows through the galvanometer, but only Ig should pass through the galvanometer. Okay, the rest of the 10 amperes minus 20 should pass through the shunt. So that is that question. And then the thing is, this 10 amperes which passes through the shunt, these two are in parallel, right? The G and S are in parallel. So 10 into S is the voltage across the shunt resistance. Right, 10 ampere current passes through the shunt. Actually not exactly 10, it will be 10 minus this Ig, but because Ig is small, right, it is 0.02 ampere. 10 minus 0.02, we approximated it as 10 itself. So 10 into S is the voltage across S. Ig into G is the voltage across galvanometer. Then we equated it. Okay, so that is it. You should revise galvanometer a bit if this is not clear. Next is binding energy of C612. Okay, so binding energy is, firstly, count the number of protons and neutrons. So the number of protons is 6, number of neutrons is mass number minus protons, which is also 6. Okay, so now the mass defect is 6 times mass of proton minus 6 times mass of neutrons, not minus, plus. So mass of protons and mass of neutrons are given in AMUs, U, right? Now what is the mass of C612, right? This is how one AMU is defined, right? So if one U's definition was 1 by 12 times the mass of C6, 12 atom, right? You guys should be remembering that this is how one AMU was defined. This was 1 by 12th the mass of C612 atom, right? So which means mass of C612, we can write it as 12U. So minus 12U. So that's why the mass of C612 is not given. Typically, if it was some other atom, they will give us the mass, okay, in AMUs. Now this you will get in AMU. Now for the binding energy, it will be this mass defect multiplied with, if it is not given, we will use the value 931.5, right? And this answer will be in mega electron volts. Okay, so that is it. That is binding energy. Sometimes they can also ask binding energy per nucleon. So you have to divide with number of nucleons, which is 12. Okay, so this answer will be first option. Yes. Next is speed of light is 2.12 into 10 to the power 8 in a medium of equilateral prism. Then find out minimum angle of deviation. This is another formula based application. So firstly, if I have the velocity in the medium, I can find the refractive index of the prism. It will be C divided by V. Okay, so it will be like 3 divided by 2.12. So this will be 1.415. Okay, so this way we can find the refractive index of the equilateral prism. So angle of the prism is 60 degree basically. Okay, so now it's just there is a formula for delta minimum angle of deviation, and the relation is with the refractive index of the prism. It is sine of A plus delta minimum divided by 2 upon sine of A by 2. Okay, so n is 1.415, angle of prism is 60, so this is sine 30, so taken to the left side it becomes half, and so this thing, this is 0.707, right? And now the thing is sine of something is equal to 0.707. So now you need to kind of take the guess what will this angle be. The answer is it will be approximately 1 by root 2, right? This can approximately written as 1 by root 2. So sine of which angle is 1 by root 2? Answer is 45. So this thing will become 45, right? So A by 2 is 30 plus delta minimum by 2 is 45, and you get delta minimum as 30. Okay, so that was how we do it. Yeah, 30. Next, hydrogen atom electron jumps from state I to F. Radius of the circular path of electron in state I and F are Ri and Rf. Radius ratio is given. Rydberg constant is given. Find wavelength of emitted photon. It's also mentioned that Ri and Rf are minimum possible radiuses. Okay. So which means if radius, so firstly the radius of the nth hydrogen orbit, right, electron orbit is a naught n square, right? So a naught is the 0.529 angstrom. So if the radius ratio is given Ri by Rf, it is equal to Ni by Nf the whole square. Now because it's the minimum radius, this n will be the minimum possible integers. So Ni by Nf is 2. So what are the minimum integers? So the minimum integers will be, minimum natural numbers will be Ni equals 2 and Nf equals 1. Okay. Now once I know Ni and Nf, I can use Rydberg formula to find the wavelength of the emitted photon. So 1 by lambda equals Rydberg constant 1 by n1 square minus 1 by n2 square. Okay, substitute R and convert it into angstrom. Okay, it will be 30 actually. Like A by A, so A is 60 plus delta min by 2. I guess you are saying this is 45. Okay, that's fine. All right, so this question, I guess it is clear. It's just Rydberg formula application. Okay. Next, ideal gas, n number of moles, CV is given, gamma is given, TF, TI is given. Question is, assertion is NCV TF minus TI. What is written on the left hand side? It is change in internal energy, right? This is equal to NR delta T upon gamma minus 1. So this I just covered a while ago. It is negative of the work done in adiabatic, right? The work done in adiabatic is NR delta T upon 1 minus gamma. So here, as you can see, there is gamma minus 1. So it is negative work done in adiabatic process. So what they have mentioned is delta U plus work equals 0 in the adiabatic case. Okay. So even though it's like, this is a memory based problem, but the assertion should be for an adiabatic process. Okay, for an adiabatic process, this should be true. Now the question is this true? Answer is yes, because delta U plus work is heat transfer delta Q, right? And Q is 0 is what this equation is telling us. And that is true, right? So assertion is true. Next is, they are saying gamma equals 1 plus 2 by F. That is also true. It's a formula for, if you do Cp by Cv, it will come out to be 1 plus 2 by F. This is also true, but they are not related to each other, right? This is not the reason explaining this. So they are correct. Both are correct, but they are not the correct explanation. The reason is not the correct explanation for assertion. All right, that is it for this question. Next, LED and logic gates circuit is given in the figure. For what combination of A, B and C both LED will glow? So there is an LED over here. For both of them to glow, both of them need to be forward biased. Okay. Now, On the negative terminal, it is grounded. So you can think of it like a 0. Okay. So for it to be forward biased, now the input at this particular terminal should be 1, and over here also it should be 1. Okay. Now if this input over here should be 1, this is an OR gate. Okay. Now A, B and C can be 0 or 1. So we need to think of combinations which will make it possible for this node to be an input 1 and this node to also be an input 1. Only then both the LEDs will be forward biased. Okay. So let's say B is 0 and A is 1. Okay. 1, 0 passing through an OR gate will make it 1. Okay. So what all combinations are there just for this OR gate? So A-B combination can be either 1, 0, 0, 1, or they can both be 1, 1. Okay. If A-B combinations are any one of these, then the input at this node will be 1. Okay. Then only this LED will be forward biased, which means it will glow. So 0, 0 is not possible. So this option is clearly wrong. Okay. If 0, 0 exists, the input at this node will be 0, which means the LED won't glow. Now coming to C, so this B and A, after passing through this OR gate, it reaches this AND gate, and of course here the input will be 1. Now if I say A is equal to 0, then the output here will be 0. Okay, then the output here will clearly be 0, which means A cannot be 0. A has to be 1. Okay, only then the input reaching here will be 1. Only 1 and 1 will give the input here as 1. Okay, and C also 100% has to be 1. This 1 and 1 will give an AND output of 1 here. Okay, for AND gate, both the inputs has to be 1. Only then the output will be 1. So I hope that is clear. So A has to be 1, C also has to be 1. B can be 0 or 1. Okay. So there are two answers for this. First answer is all of them are 1 or 1, 0, 1. A and C has to be 1. B can be 0 or 1. So the only option here is the first option. Okay. So that is it. It's option 2. Are you saying for this question? No. Here if C is 0, then this input at the AND gate will be 0. And if one input is 0, here it will be 0, which means the LED won't glow, right? 0, 1, 1. If A is 0, then here the input is 0, then here it will be 0, right? So A cannot be 0. Okay, Mohammed, I hope that is clear. A cannot be 0 actually. If A is 0 here, AND will output 0, and if a 0 enters this AND gate, it will be 0 here. So A also cannot be 0. If we would gamma equals 1 plus 2 by F in RHS, so reason actually no reasons. No, the reason is like after applying first law, right? So that's when we come to this conclusion, right? After applying first law and then finding out the work done is how we come to this conclusion, right? This is just they are stating another formula. So these are two independent facts, right? Yeah, you can put gamma here and come to the same formula, but the explanation, if you're explaining the why in adiabatic process this relation is true, the explanation should be first law, right? First law of thermodynamics, and plus the work calculations, right? Okay, next, this question I hope is clear. Next, we have charged particle moving in a magnetic field with acceleration given. So Q is moving with some velocity in a magnetic field. Now V and B can be in some angle, we don't know. But one thing is for sure, we can say that the force is proportional to V cross B, in the direction of V cross B. V cross B is out of the page, right? So force is along V vector cross B vector, which means this is actually perpendicular to V and B. Okay, and acceleration is parallel to the force. If acceleration is parallel to force, which means acceleration and velocity are perpendicular, or acceleration and magnetic field are perpendicular. Okay, acceleration perpendicular to magnetic field. Okay, if two vectors are given and they are both perpendicular, their dot products will be 0. Okay, 3 4s are 12 minus x equal to 0, taking dot product. So x is equal to 12. Okay, x is equal to 12. Okay, so here the acceleration and magnetic field are perpendicular because it's a charge moving only under the magnetic field influence. Okay, so that is it. YDSC, okay, so this question is of another formula one only. So what happens to fringe width when the setup is dipped in a refractive index of medium? Medium of refractive index mu. So the answer is the new fringe width becomes the original fringe width divided by mu. Okay, so because the fringe width formula is this one. Now D and capital D are geometrical parameters, they don't change. But the wavelength of light, it becomes 1 over mu, 1 divided by mu. Okay, because the source does not change, so the frequency of the light wave remains constant, which means the lambda value changes, right? So you must be knowing this. So when we dip the medium into another medium of refractive index mu, fringe width becomes 1 by mu. Okay, so original by refractive index will be 2. So the new fringe width is 2. Alright, next. AC circuit, frequency RNC having angular frequency. So we have an RC circuit, okay. Angular frequency omega, peak current value is given as I. So first equation, I equals peak current equals peak voltage divided by impedance, net impedance. So this is an RC circuit, right? So impedance, if I have to write, it will be R square plus XC square. I'm just using the symbol X. In the second scenario, omega is becoming omega by 4. So XC is 1 by omega C. So if the omega becomes omega by 4, the reactance becomes 4 times. So in the second case, peak current is I by 3. So V is maintained as such, divided by square root R square plus XC becomes 4 times, right? So this becomes 4x the whole square, which is 16x square. Now you take a ratio and you can get the answer. Yeah, I guess it's this one. Let's see. Third option, no, it's actually this one. Square root of 7 divided by 8. Okay. Now it's just, you just have to take ratios. So 9 will be equal to R square plus 16x square divided by R square plus x square. So 8R square equals 7x square. So the answer is, what we need is resistance and reactance, R by X root of 7 by 8. So third option. Okay, Arpant? It will be third option. Next is, this is a continuity equation only problem. So here through a pipe, at the inlet we have velocity 20 centimeters per second, 10 centimeters square. multiply them together, you will get the flow rate. Okay, inlet flow rate is 20 into 10, 200 centimeter cube per second. 200 ml per second is the water flowing in, and over here we have 10 small holes, right? So 10 times, now we need to find the flow rate through one hole, okay, and that we can get as area of one of the holes times the velocity through one of the holes. Now the question is, we need the velocity through one of the holes. Area is given, I guess. Area is 30 mm square. So this A, we will write it as 30 mm square. Okay, all you have to do is convert it into centimeter square, and then you can solve for V. Inlet velocity, inlet flow rate equals outlet flow rate. So the answer will be the first option once you solve it. Okay. All right. Next is oscillations. We have a ring, something like this. So this is the axis of the ring. So basically what that means is the oscillation is like into the page and out of the page. Okay. So we need a time period of small oscillation of the disk. So basically we push the ring into the page and it oscillates about this axis. So the center of mass is over here at a distance of r below the hinge, right? So if I push it inwards by some distance, so I'm going to observe it along this axis, okay, along this axis. So this will be the axis, and let's say this is the r radius. The center of mass is at this point, so I am going to include the mg over here. Mg is like this, okay. Now if I push the ring inwards by a small distance, this will rotate by some angle, something like this. So let's say this angle is theta, and the new mg vector will be like this, downwards. Okay, so now this will rotate like this. Okay, so the torque about, so this is the hinge line. The torque of mg is going to be mg into this r sine theta, right? That is the clockwise torque, mgr sine theta. We'll put a negative sign because theta is positive in the counterclockwise sense, torque is in the clockwise sense. So minus mgr sine theta is the net torque. This is equal to moment of inertia about this axis, which is basically this axis. So we use parallel axis theorem, right? About this axis, this is a disk. So about this axis, moment of inertia is mr square by 4. So we add a mr square to get the moment of inertia about this axis. So about this axis it is 5 by 4 mr square. So net torque equals I, which is 5 by 4 mr square alpha. Sine theta is approximately theta because this angle is very small. M cancels out, R cancels out. So alpha is minus 4g divided by 5r into theta. Alpha proportional to minus omega square theta. And so time period will be 2 pi square root 5r by 4g. Okay. This is the SHM equation. This will be omega square. Okay. Second option. So this is, you're pushing it into the page. So I am looking at it from the side view, and this is the picture. So this is the plane of the disk, and the plane itself gets displaced by a small angle theta, and this is how the motion will be basically. Okay. The mg vector will be at the center of mass, and the center of mass is at a distance of r from the hinge. So after that, it's moment of inertia calculation using parallel axis theorem. Then it's just tau equal to I alpha, and then you have to compare it with the SHM equation. Alpha equals minus omega square theta. Time period will be 2 pi by omega. Okay. Next, length of image of rod AB. So there is a rod AB here. we have to find the length of its image. So the important thing to notice here is this is not a tiny rod like the usually. There are two types of problems. In the first type, the rod is so small, like 1 mm length, right, compared to the object distances, right? Object distances will be like 30 centimeter, etc., and the rod's length is 1 mm. In this case, we can use the axial magnification formula, but here the rod's length is 10 centimeter, which is not a small rod, it's a finite length rod. Okay, so here what we have to do is we have to find the image of this endpoint A and the image of his endpoint B, and then the length of the rod, length of the image will be that distance AB. Okay, so this is a concave mirror, so focal length 10. So this is the center of curvature, right, 20 centimeter, and the object placed at C, the image will also be formed at C. So image of point A is exactly at the point A, firstly. Now for B, we will apply the mirror formula, 1 by V plus 1 by U. Object distance is 30, so 1 by minus 30 equals 1 by minus 10. So this will be 15, I guess, minus 15. So which means the image of this point B will be somewhere over here. Okay, and the image of the rod will be like this. A's image will be at A only and B's image will be at 15 centimeter. So what is the length of the rod? It is 5 centimeters. Okay, so that's how we have to do for finite length rods. Okay, so answer will be 5. The length of this purple line is what we have to find. Yeah, image of B will be at 15, but the length of the rod will be 5. Okay. Next, nuclei A and B form nucleus C. Binding energy per nucleon is given for A, B and C. The energy produced. So this extra energy produced is just the energy of products minus the energy of reactants. Okay. So for product side, there are 10 nucleons. So multiply 10 with 6, right? Binding energy per nucleon of C is 6. Multiply that with the total number of nucleons, 10. For reactants, we have B4, so 4 nucleons. And for B, the per nucleon energy is 7. Okay, and for A, we firstly, per A has 3 nucleons, but there are 2 A's, right? So 2 times per number of nucleons times binding energy per nucleon. Okay, this will give us the energy released. Mohammed, the session will be over soon, so we only have 3-4 more questions. Okay, so it will be over soon, just 4 more questions. All right, so yeah, this question I hope it's clear. Okay, 2, second option. So this is a problem based on equivalent battery, and we need to find the voltage VAB and IBA. So this is the branch AB. We need to find the potential difference across this branch, and also the current in this branch. Okay, so basically everything else, so what we can do is observe that the combination, like this we can treat it like including this. So there are like 4 parallel cell combinations whose EMF is same in the same sense also, right? It's towards the positive terminal is on the left, and they're all 27, and the internal resistances are all 3. So we can form a equivalent battery, and the other branch is a 6 ohm resistor. So we have an external resistance of 6 ohm and an equivalent battery and an equivalent small r. So this we have to replace with R equivalent and E equivalent. Now E equivalent, because all of them have the same EMF, E equivalent is 27. Okay, but the formula also you should remember, which is E equivalent by R equivalent equals sigma EI by Ri. So however many combinations are there, you have to sigma it, E1 by R1 plus E2 by R2, so on. But because all of them are 27, E equivalent is 27. For R equivalent, you just have to find the parallel combination resistance of these 3 ohms, which will just be 3 by 4. Okay. So this is the equivalent resistance, equivalent combination of this whole resistance. The 4 cell combination, we use the equivalent battery, and what's left is this 2 plus 2 plus 2, which is 6 ohm, like that. So now the current through the 6 ohm resistance we can find using KVL. That current is V divided by resistance, which is 6 plus 3 by 4, that will be 27 divided by 4. So this is 4 amperes. So the current through 6 ohm resistance, this I, is 4 amperes. Okay, but what we wanted was the current through AB, this AB branch. So if I know the current in this branch is 4 amperes, if this point is A, then this point can also be considered A, right, because it's connected with a connecting wire. So what is IR in this branch? So this branch's resistance is 6 ohm. So 4 into 6 is 24, which means VAB is 24 volt, right? Now if it is 24 volt, if the potential across these two terminals are 24 volt and there is a battery of 27 here, then the potential drop across this will be 27 minus 24, which is 3 volt. 3 volt is the potential across this resistor, which means if 3 volt is the potential and 3 ohm is the resistance, current in this branch, let's call it I dash, will be V divided by R, 3 by 3, 1 ampere. Okay, so the answer will be 24, 1. Next, AC circuit, resistor 100 ohm, inductor 0.1 millihenry, capacitor are connected in series. So series RLC circuit, peak voltage frequency is given, power factor of circuit is half. Okay, so this is, so firstly in these questions just draw the impedance triangle. So this is the net impedance, this is XL minus XC, this angle is the angle theta, and this is the resistance. Okay, and here cos of this angle theta is what we call the power factor. So if that is half, then that means this angle is 60. Cos 60 is power factor. It's given that XL minus XC magnitude is, okay, so this magnitude is what we have to find, basically this side's magnitude. So we know resistance is 100 ohm, so tan 60 equals mod of XL minus XC divided by resistance, which is 100 ohm. So the answer is 100 into tan 60, 100 root 3. Okay, so they have said it is equal to root 3 alpha. So this is root 3 alpha is 100 root 3. So alpha is 100. Okay. So this is another formula based question. In the impedance triangle, this side is XL minus XC and the base is R. This is the total impedance, and cos theta is the power factor. And now this is only true for the series RLC circuit. And now they wanted the length of this side, basically mod of XL minus XC. R is given, so I just used tan 60. Okay. This is a question on photoelectric effect. Graph on stopping potential versus frequency. So stopping potential E times the stopping potential equals K max, maximum energy photoelectron that was emitted, that electron's kinetic energy, which is actually, so we want the graph between, so this graph is plotted against frequency. So energy of photon, we will write it as hf minus work function, right? Now the question is, in which case will the electron eject with maximum kinetic energy? If we are for given frequency, okay, so if the frequency remains fixed, so basically this is going to be a straight line, and that's why the graphs are straight lines for different materials, okay, and the materials are x1, x2 and x3. So the thing is, if you observe the y-intercept of this straight line, it is going to be proportional to phi. Of course it will be negative, right? That's why if you extend these, that's why all the y-intercepts are negative, but the magnitude of this y-intercept, it is proportional to the work function psi. So this graph, if I call it as psi1, this is the smallest work function. This material will have the smallest work function. Now if the work function is small, then K max will be large, right? K max is equal to hf minus work function. So if work function of first material is the smallest, it will have the largest kinetic energy for the emitted photoelectron. So x1 is the, so the order will be like this: x1 greater than x2 greater than x3 for the kinetic energy of the electron emitted. Okay, so that is what this graph is telling us. Slit of width A is illuminated by light of wavelength lambda. The linear separation between first and third minima, the diffraction pattern produced on a screen. This is a single slit diffraction question. So this is, let's say, the screen. So in the single slit case, the central, the pattern I am just drawing of intensity, it looks something like this for the single slit diffraction, okay, and this is the first minima point, this is the second minima point, this is the third minima point, and so on, okay, where the basically the curve touches the screen, right? This is the graph of intensity as we move along the screen. The central maxima gives us a maximum intensity. Also another thing to remember here is what is this angle, okay? This angle for the first minima point, let's call it theta 1. This angle for the second minima point, let's call it theta 2, and so on, right? So the theta value for the nth minima is n lambda divided by A, where A is the slit width, okay, and lambda is the wavelength. So if you put n equal to 1, you will get the first minima's angular coordinate. So this angle, right, this is the first minima. This angle from the horizontal line, this theta, is lambda divided by A. This angle is lambda divided by theta 1 is lambda by A. Similarly, the second maxima will be at second minima will be at 2 lambda by A. The third one will be 3 lambda by A, and so on. So the thing is, they wanted the linear separation, I guess, the linear separation. So what that means is, so this is the second minima point, this is the third minima point, they wanted this distance, okay, delta y, 1 3, not 1 3 2 3, okay, first and third, my bad. So this is the first minima, second minima, third minima. They wanted this delta y, 1 3, not the angular difference. So what we'll do is we'll say this angle is theta 1, lambda by a. So if I do angle multiplied by this distance using the arc length formula, radius multiplied with theta, so this length will be lambda by a angle into radius, capital D. Okay, that will give us this tiny distance. We can do this because the angle is small. All these angles are very small. Now for the third minima, the angle will be 3 lambda divided by a. Okay, so this angle we have to multiply with d, that will give us this y distance. That will be 3 lambda by a, the angle of the third minima, angular coordinate of the third minima multiplied with d distance. Subtract them, you will get this distance. So 3 minus 1 is 2. Yeah, so in this question, so the question is, okay, in this graph, firstly, we can comment on the work function ratio. Okay, if this the question was compare their work functions, then what you will do is you will compare their y-intercept. Okay, so look at this relation. Here stopping potential is hf divided by E minus psi divided by E. Okay, compare it with y equals mx minus c. Okay, so this c is the y-intercept. So if you put x equal to 0, you will get y equal to minus c. So larger the value of c, larger the y-intercept. Okay, so what exactly is c? C is proportional to this work function. So larger the value of this y-intercept, for example, in these three graphs, this x3 curve is the one with the greatest y-intercept in magnitude, which means the work function will be the greatest for the x3 graph. Okay, so psi 3 is the greatest, then comes psi 2, then comes psi 1. Now in the last part, they are asking which will eject photoelectron with maximum kinetic energy for some fixed frequency. Okay, that has nothing to do with this graph. So that max kinetic energy is some h times constant frequency minus the work function. Now this will be maximum for the smallest work function. Okay, and the smallest work function is x1 has the smallest work function, which means that will give us the k maximum kinetic energy for electrons. Okay, frequency is the same for a given frequency, for a fixed frequency which gives maximum kinetic energy. That's the question. So that will be the one with the minimum work function. Okay, smallest psi will give us the greatest k max for the electron. Okay, so I hope this question is clear, and yeah, that is it. So that was all the problems. So okay, so if that is it, guys, good night, and session is over. Arun, this was the last question. It's over. Okay, so good night, guys. All the best for I guess we will have one more session tomorrow, because tomorrow is a holiday, right? Day after tomorrow will be the last shift. Okay, so good night, guys. We will see tomorrow. Yeah. Yeah, for tomorrow, like, what do you guys want me to like bring? So like in these sessions, in the past sessions, I have taken questions from 2026 and 2025. Okay, so like for tomorrow, like what questions do you want? Do you have any suggestions, or do I? PCM full? Nah, I'm only taking physics. I don't know about maths and chemistry. So the maths and chemistry, the teachers are taking like the discussion sessions, right? So they will be tired. Rotational, okay, I'll take rotational. What about CM? CM means, do you mean center of mass? PYQ, okay. PYQ, like we basically covered all like 2026 subtypes, 23, 24, 25, okay. Yeah, I'll include rotational motion. How much percent chance? Similar question. Rohit, you should just check the April shift question papers. You would see a lot of questions just repeating. Like it's as if they are just playing with the same type of questions again and again, right? Like I made these PDFs for the last few sessions, right? And it's the same questions that they are asking in the past few shifts. Like they just constantly repeat the same thing. So you should take a look at the April shift questions, right? The memory based. You will see a lot of them just repeating from these sessions, okay? How did 8 session 2? Important questions tomorrow. Yeah. Okay, so we'll meet tomorrow, guys. I'll bring more important questions. Okay, good night. So yeah, that is it.